And we are live. Okay, so we're still in pre-algebra, and we're going to be doing something special here, which is the Cartesian Coordinate System, graphing of points, and the table of values, some cool stuff, which happens a lot when we're in algebra. So in pre-algebra, we kind of start getting used to it. The dog is lost. One of these dots is her location. Okay, I'm just kidding. I'm not going to try to put together some scenario where we figure out a lost dog with the graph. Although, if I were to put my mind to it, I'd come up with something. What I am going to do is let the dog off the hook by putting her down. She doesn't really look like she's super comfortable right now, but she will be in a second. Down you go. Lie down. Stay. Be a good girl, and then if you're really good, I will feed you. Okay, so I'm Doug. This is Stoke City. This is a team that was in the Premier League when I bought this jersey, but I don't think they are anymore. But anyway, let's get into the math. Okay, what we have is first I want to talk a little bit about the lingo, the terminology. The Cartesian Coordinate System is this thing, this type of graph. And in this type of graph, in either of my examples, you have an x-axis, which is labeled here with an x, and there's an arrow there, and the y-axis, which goes straight up and down and is labeled with this y. Make sure that fits into the rectangle. And then we usually will do this on graph paper. It works a lot better if you have graph paper. If you try to do graphs without graph paper, it can get messy. It's possible, but it gets messy. Graph paper is good. What we're going to do is we're going to talk first about being able to identify points, these dots that I've put on here, with their coordinates. The coordinates are numbers that represent where they are left to right along the x-axis, and at the same time where they are up down with respect to the y-axis. We're able to give a coordinate pair, which is a way of giving the location of a point. What else have I? And then, where the two axes meet is this point right here. I put a dot on it in this graph. But that's called the origin. And it is the point where the coordinates are 0 and 0. Every graph has an origin, whether there's a dot on it or not. So the origin is right here. It's where the two axes meet. It's kind of easy to find. I am trying to use colored chalk, which is something that doesn't work really well on video, but I'm doing my best here because it's hard to understand anything that's going on with this graph paper if you don't see clearly where the x-axis and y-axis are. So I did these two axes in orange, and all of the other lines of the graph paper are done in white. So the first thing we're going to do is we're going to identify all of these points. I'm going to give each point a letter, and then we're going to write the coordinates of that point in here in this table of values. So that's what a table of value is. A table of values is a table that's full of values. Okay, that might have seemed kind of obvious. But the x-coordinate of each point goes here on the x side, the y-coordinate goes on the y side, and it is something that we get used to really quickly once we have started dealing with the Cartesian Coordinate System. I need some chalk. Okay, let's start with point A. Well, we don't know which one is point A because I haven't labeled them yet. But I'm going to label a point, and I think I'm going to label this point here as point A. So now our challenge is to read the x and y coordinates of point A from the graph so that we can record that information here next to A in the table of values. And I'm also going to show you what a coordinate pair looks like when you represent it outside of a table of values. All of that with our very first point. Okay, so A is at a point, if we have scaled the axes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, which is the most common way to scale them. I didn't write all the little numbers on mine because, let me just confess something right now. The thing that makes this is an easy lesson and it's a very difficult lesson. It's easy for you and it's difficult for me. What's difficult is having to draw this. It took me a while to draw these. I have to fuss with the ruler for quite some time. The issue is that if I use one and then erase it, I don't have time to draw another one while the clock is ticking in the video. I don't want to do that. So what I'm going to do is try to erase everything that I did on the graph without erasing the graph itself. Things will get a little chalk dusty in the process. So one thing that I did to try to keep things from being too cluttered was I did not put the numbers. So starting at the origin, which has the coordinate 0, 0, I am going to go to x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. And that's as far as this particular graph goes. I didn't try to make it bigger than that. So I can draw a little 1 here. Might not be the easiest thing to see in the video. Let me see. Oh, that's not so bad. And then I can also draw a little 1 here for the y-axis. So I'm marking where 1 is on the x and where 1 is on the y. And that's how all you see in terms of the scaling of the axes, because it's enough information. The person who's reading the graph can see, oh, okay, this one goes up by 1s, 1, 2, 3, 4, 5. They can figure out the rest. Same with this one, 1, 2, 3, 4, 5. The thing that's cool about these coordinate systems is that they also allow us to use negative numbers. So therefore, if I'm going to the right along the x-axis from the origin, I get to 1, 2, 3, 4, 5. But I can go to the left and get to -1, -2, -3, -4, -5 in this one. And that should sound familiar because it sounds like a number line. So often, before we have dealt with these coordinate systems where we have both x and y, we've already done some work with the number line, and the number line looks like the x-axis because basically the x-axis is a number line. And the y-axis is another number line. It's just one that happens to go up and down instead of left and right. The y-axis reminds me of a thermometer. There's a lot of crossover between these ideas. Anyway, I'm not going to be writing all of these numbers because it's cluttered enough. I want to figure out where a is, and the thing I do is I don't try to do the x and the y at the same time. I'm just going to figure out where a is along the x-axis and figure out its x-coordinate, and then figure out where a is on the y-axis and figure out its y-coordinate. Together, those give me all the information I need. So point A is 1, 2, 3 units to the right of the origin along the x-axis. Even though it's up there, I can still count along the x-axis until I get to its location left, right. So 1, 2, 3, its x-coordinate is 3. And its y-coordinate, I'm doing the same thing, but I'm counting up along the y-axis. So here's 0, there's 1, there's 2, I got there. A is at a height of 2 above the x-axis along the y-axis. So its y-coordinate is 2. And in a table of values, that's what it looks like. You could glance at this and realize, oh, okay, the x-coordinate of point A is 3 and the y-coordinate is 2. Another way that we can represent this when they're not inside a table is like this. You use round brackets and you write 3, 2, and then you close the bracket. So that is the coordinates of point A. This is the way they look when we don't have them inside a table, and this is the way they look when they're inside a table. So that isn't very difficult, and it is kind of fun. We're starting over here in the top right quadrant because that's where all the positive numbers are, so we start with some of the easier ones. Let's find the coordinates of point B, which I will say this one is point B, this dot right here that I'm pointing to. So, how far to the right of the origin do I have to go to before I get to where B is? Only 1 unit. The x-coordinate of B is 1, positive 1. I'll just write this type of 1. And then what about the y-coordinate of B? I have to count up along the y-axis, 1, 2, 3. So the y-coordinate of B, point B, is 3. And there we go. And I can write the 1 and the 3 with a comma in between them in brackets if I want. But I'm not going to list all of those. I'm just going to fill in this table. So all of these have had x-coordinates and y-coordinates that are all positive numbers so far. And that's where I want to start. I don't want to mix in the negatives until the students have had a chance to get used to some of this. I can't believe I've already been talking for almost 10 minutes and we're only finishing the second point. But that's the way it is when you start. The first examples always take the longest to talk about, and then things tend to speed up. So let's go and check out this point. I will call this point C. And it's way over there as far as I can get within this little coordinate system that I drew on my graph paper. But of course, if you have regular graph paper, you could make your graph much bigger and be able to go to much larger numbers. You could, with a regular piece of paper, you can easily get up into the low 20s for the x coordinates and the y coordinates, or all the way over to the negative 20s for both x coordinates and y coordinates. So that a larger graph allows you to fit larger numbers. We can also scale the graph differently, but we're going to stick with today's lesson with graphs where we're just going up by ones like this one, because it's so much easier for the teacher who's trying to do it with a chalkboard. I need a sip of my fizzy water. Calamansi, citrus, and strawberry, one of my favorites. Okay, thus rejuvenated, I move on. Point C, I had to go 1, 2, 3, 4, all the way to 5. X equals 5 to get to where the C is. So the x coordinate of point C is 5. And then the y coordinate, 1, 2, 3, 4, which is as high as I could go on this graph. So y coordinate of 4 for point C. It is getting easier, isn't it? Okay, so let's start doing some of the other stuff that happens, because we have run out of points that are over in this quadrant. But wait, what about this one? This one, it's a little special, it's a little different. When we're counting how far to the left or right from the origin do I have to go in order to get to the position of this point, and I will label it point D right now, I didn't move to the left or right at all. I did not move to, see there are my fingers on the origin, I did not move to the right or to the left from where I am now. It's straight above. So therefore the x-coordinate is 0. And that's weird at first, but then you get used to it very quickly. So any point that has the dot right on the y-axis is going to have an x-coordinate of 0. Okay, it doesn't mean it has to have a y-coordinate of 0. Its x-coordinate is 0, because x is where we're measuring how far left or right we've gone. This one has not gone any distance left or right, so it has gone 0 distance to the left or to the right. So therefore it makes sense that its x-coordinate would be 0. But its y-coordinate is not 0 because it is higher than that. It's higher than the origin. In fact, it is 2 units above the origin, so its y-coordinate is 2. So therefore 0, 2 are the x and y coordinates of point D, and it's not so weird after all. And then how about we give this one the label E, which is the dot that's right on the origin. Okay, well, if we understood D, we're going to understand E. For E, we did not go to the left or the right at all, and we did not go up or down at all from the origin, because point E is on the origin. Therefore, point E has the coordinates 0, 0. And that's going to happen sometimes. Okay, now we've run out of all the ones that don't have negative numbers in their coordinates. We're going to have to deal with some negative numbers. Let's start with these ones. So I'm going to start with this point right here, and I'm going to call it F. For F, we had to go to the right of the origin by 2 units. 1, 2, so its x-coordinate is 2. Okay, so something's happening that involves negative numbers, but the x-coordinate's not negative. The x-coordinate is 2 because I went 2 units to the right of the 0 on the x-axis. But for the y-coordinate, I had to go down by 1 unit. So from 0 I went down 1. Well, if I'm going up to 1 when I go up, it means that if I'm going down by 1 unit, I'm going down to negative 1. So negative 1 is the y-coordinate. And the fact that it has one coordinate that's a negative number does not stop us. We can still do this because we know how to handle integers. This is one of the reasons why we reviewed integers before we got into this unit. Interesting how all these different types of math tend to overlap each other, and really there is just only one topic in math. It's called math, and it's all interesting and it's all fun. It's all just something you have to get used to, and once you get used to it, it becomes easier. So let's do a couple more of the points that are in this quadrant. Yet there's another term that I didn't bother mentioning, quadrants. We have 4 quadrants in this Cartesian coordinate system. Here's the top right quadrant, here's the top left, here's the bottom left, here's the bottom right. Right now we're dealing with the bottom right quadrant, and what pattern are we starting to see? Well, I don't want to really call it a pattern when we've only done 1 point, so we'll talk about the pattern again after we do 1 more point. I'm going to put G as the label of this point here, and to the right of the origin, that is 1, 2, 3 units to the right of the origin, so its x-coordinate is 3. And then below the origin, it is 1, 2, 3 units below. Oh, so its y-coordinate is negative 3. 3, negative 3 is a perfectly reasonable coordinates for a point. And then you get to see sort of something happening that, yeah, it goes 3 to the right and 3 down. There's something sort of patterny about this, that you can see something special is happening in this diagonal line that's kind of halfway between the x and y axes. Oh, that's the pattern, is that the x and the y coordinates have the same number, although they don't have to have the same sign. And then we look at the pattern. Okay, now we can see a pattern emerging. In this bottom right quadrant, we're going to have x coordinates that are positive and y coordinates that are negative. So does that mean I can predict that this point here, which I'm going to call h, is going to have a negative y coordinate and a positive x coordinate? Yes, I can predict that. And I feel quite confident about this. So let's identify h. H is 1 unit to the right of the origin, so its x coordinate is 1. And it is 2 units below the origin, so its y coordinate is negative 2. And yes, the pattern holds true. Interesting. That quadrant has positive x's and negative y's, and that's something you can count on, and it's starting to notice patterns like that and realize you can count on them is part of what makes this eventually become easy for the students. Okay, let's try this quadrant here. Now we're in the top left quadrant. So here, we only have 2 dots. I think I'm going to go way over and do this dot next. I did G and H, so this is going to be I. Okay, so point I is, wait, how many units to the left of the origin? Quite a few. Negative 1, negative 2, negative 3, negative 4, negative 5. Notice how I'm saying negative, because the positives are over there, 1, 2, 3, 4, 5. Just like in the number line, the negative numbers are what happens to the left of the 0. So negative 1, negative 2, negative 3, negative 4, negative 5, its x-coordinate is negative 5. And its y-coordinate is 1. That was a fast one to find. It's only 1 unit above the origin. Its y-coordinate is 1. And we start seeing a pattern emerging again. Can we trust that this is sort of the opposite pattern we just saw? In this top left quadrant, am I going to keep on getting x-coordinates that are negative and y-coordinates that are positive? And the answer is yes. Because x-coordinates negative happen when the point is to the left of the y-axis, and y-coordinates that are positive happen when 2 points that are above the x-axis. And again, these patterns are something we can count on. So I is done. I need j. This is going to be j. J is how many units to the left of the origin? 1, 2. It is only 2 units to the left of the origin, but to the left means negative 2. J has an x-coordinate of negative 2. And then 1, 2, 3 units above, its y-coordinate is positive 3. This is becoming easy, isn't it? And these are the only 2 we have left. They are going to be K and L. I'll just write in both of the labels. Let's do K. K is 1, 2, 3 units to the left of the origin. That means its x-coordinate is negative 3. And it is 1, 2 units below the x-axis, so its y-coordinate is negative 2. So now we're combining the same thinking that made us realize that these would have negative y-coordinates, and these would have negative x-coordinates. So these are going to have negative x and y-coordinates, and that is what's happening. And it makes sense, so it's easy to remember. It's fun to play around with and experiment with. Okay, L. Only 1 unit to the left of the origin, that's negative 1. And 1, 2, 3, 4 units below the x-axis, 4 units below the origin, so its y-coordinate is negative 4. Fun. So this quadrant, they're both positive. This quadrant, the x's are positive, but the y's are negative. This quadrant, the x's are negative, but the y's are positive. This quadrant, both the x's and the y's are negative. Nice patterns that are easy to see. And then you get those special cases that these ones that are right on an axis can have a negative coordinate, they can have a positive coordinate, but because they're on an axis, at least one of their coordinates is going to be 0. And of course, 0 is neither positive nor negative. So we don't need a negative sign. Lots of stuff happening, actually. When you think about it, there's a tremendous amount of detail in what we have been discussing to make it make sense that it would have taken 20 minutes. Wow, 20 minutes already, just to talk about all that. Okay, So what do I want to do next? What I have to do is some erasing. So this is the part that's hard for me. I want to erase without making a complete mess. I don't want to erase the whole graph or the whole table. I want to erase all this stuff off of them that we won't need anymore as we move on to the next questions. And then I want to repair my graph and my table so that I can write in some more stuff. And let's just see how chalk dusty things become. So I'm going to erase, first I'll erase all the letters from this one. Because erasing the dots, that's going to be a little bit more trouble. I'm going to keep those two little ones because I'm going to use only scaling that works this way for all of the examples that I'm doing in today's lesson. I haven't made too much of a mess. Of course, we can see these sort of circular smudges where there used to be letters. Now I have to erase the dots. That's where I'm going to start making a mess. Okay, I have no choice, so I'm erasing the dots, and of course this is also leaving little circular smudges. We have a beautiful drawing which is just a whole bunch of smudges now. I even have to erase my origin. Oh, and there's orange chalk in there, so it takes a little bit longer to clean. But I did it. Now I have to repair it. I think I'll repair that before I start messing around with the table. Okay, so I just need to sketch in lines wherever I did some erasing. It's already getting messy, I can see that. But it'll do. We'll be able to manage to use this coordinate system again. I'll avoid where the orange is for now. There's one way over here. Oh, it's quite messy in this little region. I don't remember doing so much drawing over in this section. I think I did some accidental erasing. That's pretty good. Now I'm going to finish this line. And I'm going to get my orange chalk, which means finding my orange chalk. Where's my orange chalk? I obviously had orange chalk at one point today. Oh, where's the orange chalk gone? There it is. Okay, phew. It's because it looks just like the white chalk, if you can't see the little tip. Okay, so I'm going to finish the two, fix up the two axes. And it's good as new almost. A little bit more here, there. Good as new. Now I have to erase all the x and y coordinates from the table of values. How messy is this going to get? Lots of round smudges. It's not too bad. Chalkboards are great, but sometimes they're not the most advantageous tool to use. Maybe someday I'll develop some sort of trick for drawing these graphs, these graph paper lines on my chalkboard wall really quickly. Almost there. I'll erase all of that. Okay, so now what we did the first exercise was we had dots on the graph and we were identifying them. We were figuring out what x and y coordinates they had. This time we're going to do the opposite. We're going to write in a bunch of x and y coordinates for points, and then we're going to graph them. So we have to find the spot on the graph where we want to put our dot. And I prepared ahead of time by choosing 12, is it 12? Yes, 12 more points. And I paid special attention to making sure not to reuse any of the 12 that we already used. So let's see if I actually succeeded or if I accidentally reused something. Okay, so let's do 0, -4 is going to be the coordinates for A. And now I'm not going to say them all out loud. I'll just write in coordinates for all the rest. A little bit messy at times. This isn't so bad though. finally, the last one. Okay, now let's graph them. Now the fun thing about this is I don't really have to start with A if I don't want to. I can pick any of these. So what do you think? I want to do this one, I. Negative 2, 0. How do I do this? I can see that point I has an x coordinate of negative 2 and a y coordinate of 0. Really, you just have to do one thing at a time. If you try to do it all at once, it gets kind of mixed up in your head. So an x coordinate of negative 2 means from the origin I am moving 2 units to the left. So therefore it's somewhere up and down on this line. But its y coordinate is 0, so 2 units to the left of the origin, but then 0 units up or down. Turns out I lands right there on the x-axis. And you start getting used to an idea, which is a good idea to be used to. Because I've seen a lot of mixed up students in my career as a teacher. And this thing about realizing that when you have a 0 as one of the coordinates, what does it mean? There's a little bit of slightly backwards thinking. We have a 0 as the y coordinate. When you have a 0 as the y coordinate for a point, the point lands on the x-axis. It doesn't land on the y-axis. It lands on the x-axis. So any point with a y coordinate of 0 should land on the x-axis. And point I did that. So I'm going to label I. I'm starting to wonder whether I even needed to draw this other graph. It's going to be much messier for me to do stuff on it unless I go and step right off camera. Maybe I should have just done the whole lesson with this graph. I'm going to make sure to use this graph for at least something. Okay. Now, that was fun. So we have graphed point I. I can even put a little check mark next to it to remind me I've already done it. But what I can also do is I can say, okay, I can choose any other point for my next point. I want this to be fun. And what I'm thinking is I'm just going to go and find another point that has a y coordinate of 0, because what I seem to have learned is that this point has to land on the x-axis, and that is point B. It is the point with x coordinate 3, y coordinate 0. X coordinate 3, 1, 2, 3. Y coordinate 0 means it's right on the x-axis, and I have graphed point B. Little b, I drew that b kind of small, but anyway, I'm not going to bother erasing it. So point B has also been graphed. This isn't that hard, it is that fun. It's fun. Okay, let's try and find the hardest one that we have. How about here, this one has both the x and the y coordinates are negative, so that's point L. I want to graph that where the x coordinate is negative 5 and the y coordinate is negative 1. X coordinate negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. Y coordinate negative 1. And that was point L. And I will label it. So, I mean, that's as difficult as it gets, but I didn't find it that difficult. Might be difficult to draw the letters neatly on the graph. Okay, so what else should I do? I can say, okay, what was special about L? We had figured out what was special about I and B is that they both have y coordinates of 0. L is one of those points that has both negative x and negative y coordinates. Are there any other ones? Here's one. Oh, here's another one there. That's it, there are 2 more. D and E, I want to do D and E next. I'm going to check them both off. E looks interesting, negative 1, negative 1. Negative 1 means 1 unit to the left, and negative 1 means 1 unit down. Oh, there's my E. Let's not get this mixed up. I and E are so close together. I can't be this dot, because E needs to be that dot. And there's a dot over here for, we already know how it's going to work. It gets a little tricky putting all these letters on the graph, but I think this is just fun. That's kind of, yeah, that's okay. Okay, so we did E. Negative 1, negative 1. That is the x and y coordinates of E. They're both negative 1s, and it lands in this diagonal line, and it's something that's a pattern that we get used to seeing, and it actually just makes it more fun. D, negative 4, negative 3. Negative 1, negative 2, negative 3, negative 4. That's along the x-axis. That's my x-coordinate. Negative 1, negative 2, negative 3. So D goes here. This is just fun. Okay, let's do the rest of them. How about these ones where the x-coordinate is 0? Well, if the y-coordinate being 0 means it lands on the x-axis, it stands to reason that when the x-coordinate is 0, it should land on the y-axis, and it will. But let's do point J. It has an x-coordinate of 0 and a y-coordinate of 1. X coordinate of 0 means I'm not moving anywhere to the left or the right from the origin. Y coordinate of 1 means I'm moving up by 1 unit. I did it. 0, 1 is the coordinates of point J, and yes, it landed on the y-axis. So let's find another one, and there it is. A is 0, -4. 0 means it's not moving at all to the left or to the right. It's on the y-axis, and -4 means -1, -2, -3, -4. It's down here. And that was A, so I'm going to label it as A. This is just fun. Okay, which ones have I not done yet? Let's do C. -4, 3. -1, -2, -3, -4, +1, +2, +3. There we go. That is point C. Checked off. F, -5, 2. -1, -2, -3, -4, -5, +1, +2. There we go. There's my point F. It is fun. I hope the students find it fun. F is checked off. There's only 3 more. G, 4, -2, +4, -2, 1, 2, 3, +4, -1, -2. There we go. That was G. Yes, it was. Let's label it. H, 3, -1. +1, +2, +3, -1 right here. Not much room. There's so many letters around here. I'll put the H over here. Okay. And I will check that off. We only have one left. K, 1, 4. Ah, both the X and the Y are positive. Is that the first time that's happened? Yes. And we already learned from the pattern from the previous exercise, when both of the coordinates are positive, it means it's going to land in this quadrant over here, the top right quadrant, where both the X's and the Y's are positive. X is 1, Y is 4. X equals 1, Y equals 1, 2, 3, 4. It goes here. And that was letter K. This is fun. I could do this all day. But I have already used slightly more than half of the time in this lesson. And the next bit is where I have to do some erasing. So what I'm going to do is, no, I'm saving this other coordinate system for the last thing I'm going to graph. And I'm going to do my next 3 things on this one. So I'm going to erase all of this stuff again and erase all this stuff again and get ready to do another one. But it's going to look a little different, because now we're going to actually apply this knowledge. So far we've just been practicing locating points, identifying points, using the coordinates and the graph back and forth. We're able to do this. Well, we've had a lot of practice to do this, so we're in good shape. We should be able to do an exercise where locating points helps us to draw some kind of picture, which is the sort of thing that happens in math. Okay, let me start by erasing the dots. And we're getting smudgier and smudgier with every new exercise. Erased all the dots. I'm going to repair the lines. That one is, I'll repair the orange lines last. You can see how this would take a lot of time if I were to completely erase it and have to draw it. This is actually much faster than drawing the coordinate system was in the first place. Smudgy. Smudgy everywhere, all sorts of smudge. Little smudgy circles all over the place. But I'm getting there. Okay, now I'm going to erase the letters and create some more smudgy circles. I had to repair that bit of white lines. I forgot that one. And sometimes my erasing becomes a little bit too enthusiastic, and I have to repair some lines after that. Okay, nearly done. Let's complete these lines. It's just making it worse. And any others that I should be repairing besides the orange ones. I definitely have to repair the orange ones. It looks good. So the orange chalk, which I can find, is going here here, and here. And our graph is good as new. Okay, not as good as new. Very smudgy, but still we can use it again. Now this time what should I do here? I'm going to erase all the check marks. And I'm going to erase all these letters because I'm not going to be using them anymore. But I want to keep the table of values, so I'm going to just erase all the numbers from inside of it. And I'm going to do a drawing. I'm going to graph an equation. And I'm not going to need 12 points in my table of values for this graph. But you're allowed to make as long a table of values as you want when you're graphing an equation. I'm going to make a table of values. I think I'm going to put 5 points into my table of values. But does that mean I want to erase the entire table? No. I'm going to keep the whole 12-point table, and I'm just going to fill up the top part of it. Still, I am spending a lot of time erasing and smudging things up. Okay, I'm going to graph a line. I'm going to graph a straight line, the equation for a straight line, but an easy one. I'm going to start with a nice easy one. And I'm going to have some room for some algebra. So I'm going to put the equation here. Y equals x plus 3. So we eventually do a type of math called straight lines math, where we do an awful lot of equations that give us straight lines when we graph them. But I mean, when we first seeing one of these for the very first time, we wouldn't necessarily realize it's going to give us a straight line. But we don't really have to even know that for sure right now. What we can do is we can start filling in a table of values. Like I said, I'm going to do 5 points, and then see where the dots end up on the graph. So it's a very different exercise than what we were doing so far. Let's fill in a table of values, and what I'm going to do is I'm going to say, what if x is 0? Remember this idea of evaluating. You can replace x or y or both of them with a number. What we're doing is kind of in between. We're going to replace x with a number, and we're going to do algebra to figure out what y goes with an x of 0. But I'm going to do, let me see here. I'm going to do 0, 1, and 2. But then, just to make things a little more challenging and interesting, I'm also going to use -2 and -3 for my y's. Maybe I should have waited before deciding which points I could use. I could change my mind. I'm going to start with x equals 0. If x equals 0, what y goes with that? This is called filling in a table of values. Tables of values are extremely useful. I'll go way over here. I write my equation, y equals x plus 3. But if x equals 0, that means I can write the equation again and replace x with the 0. The y is still there. I didn't replace the y with anything. Now I'm going to do algebra to find out what y is equal to. I'm just simplifying. And 0 plus 3, this is a fast one. 0 plus 3 is 3. Y is 3. So if x is 0, it turns out y is 3. Let's graph the point right away. 0 means I'm not going left or right from the origin. So my point is going to be on the y-axis. Very important thing to know. And then a y of 3. 1, 2, 3. There. I have a point. And I'm not giving these points letter names. I'm just putting the dot. That dot goes with this point in the table of values. What if x is 1? Y equals x plus 3 becomes y equals 1 plus 3, which means y equals 4. And I finish that point in my table of values, and then I graph it. X equals 1, y equals 1, 2, 3, 4. Oh, I have a dot right there. What if, and I wanted to make x equal to 2, but what's happening is I can see the trend. I can already see what's going to happen. I'm drawing a line that seems to be going up like this. And if I make x equal to 2, it's going to go right off the graph. So I'm changing my mind. I'm going to make x equal to -5. I can do any numbers I want, but it's fun to start with 0, and it's kind of easy to start with 0. 0 simplifies quickly when you do the algebra. So y equals x plus 3 is my equation. But this time I'm saying, what if x is -5? Y therefore is equal to -5 plus 3. And -5 plus 3, we know how to do our integers. -5 plus 3 is equal to -2. So I get a y of -2, and now I can see a reason why I shouldn't have filled in all these numbers in the table. The next point, I'm just going to have to erase it because I just find this point over again. But let's graph this one first. -5, -2. We have these skills: -1, -2, -3, -4, -5, -1, -2. There, that point is graphed. And now we can really start seeing our straight line. With a straight line, if you put 2 dots on the graph, you can always draw a line through any 2 dots. So you're not really feeling certain if you're correct or not. But as soon as you put a 3rd dot and you realize it's forming a nice straight line with the other 2, you start feeling some confidence that you didn't make any mistakes in your algebras. Okay, so I'm not going to make y equal to -2 for my next point because all it would do is find out that x is -5. I already know that, so I'm going to erase it. And instead of -2, I'm going to make y equal to -1. Okay, but wait, how do we do that? It's so fast and easy to replace x with a number. And then we do algebra and solve for y, but now I'm making it all complicated. Now I'm replacing y with -1. I write my equation, and when I replace y with -1, it looks like this. But I can do algebra with that. We know how to do algebra with this. This is very fast little algebras, because this is a pre-algebra course after all. So we're not trying to give the students all sorts of complicated things with lots and lots of variables and exponents and all sorts of stuff like that. Just a few simple little ones where we're simplifying, but actually we are doing algebra. Each of these is a chunk of algebra. And it's good to start with simple examples. Okay, what I'm going to do is I'm moving my equals over so I have some room. I'm going to move this 3 away from the x by subtracting a 3 from both sides. So therefore, I'm subtracting a 3 from both sides. That happened here and it happened there. Why did I want to do that? Because these will cancel now. And my x is by itself on the right side of the equals, and -1 minus 3 combines to give -4. And I have x equals -4. It's written backwards, but I can still just read it backwards. X equals -4. And it is correct. And we have a point, -4, -1. -1, -2, -3, -4, -1. Right there. Using the same skills we were using earlier in the lesson, and yet again it's falling in line with the other dots, making me feel like I must be correct. One last point. Y is equal to -3. I need some room. I'll try to do it here. Y equals x plus 3 becomes -3 equals x plus 3. I'm writing smaller so I have room. I'm going to subtract 3 from both sides. Yes, I have to write quite small. These cancel. X is by itself, and -3 minus 3 gives me -6. And I managed to finish it. -6, -3, and I did it again. I went off the edge of the graph. -6 would be over here. -3 would be here. It is actually possible still to graph it. But you can see the challenges that happen when we are trying to do a graph on a chalkboard. If I were on graph paper, I'd just use more of the page. And those lines just keep on going so that I'm able to fit extra points. But I'm also going to draw the line, because the reward at the end of doing this process is we get to draw our straight line. I didn't draw that last point very well. There. So I'm just not going to show it. And yeah, I drew a line through all 4 points. I have graphed the straight line, which is represented by the equation y equals x plus 3. I can do this. This is going to happen a lot in algebra, and it is going to occasionally give you more challenging bits of algebra to do. But at this level, we're able to do it. And that's good. It's good to know that you can do this sort of stuff, because math becomes quite magical when you start adding this sort of tool to your toolbox. I always really, really enjoy that part of math where it sort of overlaps with art, because math has a lot of overlap with art. And you might think of artists as people who never want to be bothered with math because they're so artsy, but that's not true. The artists among us realize that the artists use math quite a lot to their advantage. You can do all sorts of interesting stuff if you understand the math behind the drawing. That's my opinion anyway. I'm a math teacher, and I'm also kind of a, baby level artist. I can draw a straight line. Okay, so what do I want to do next? I want to do another graph of another straight line, and that means I have to do some erasing, but the erasing isn't quite so demanding as it was with the previous exercises. I'll erase all these algebras right away. Try not to mess up the table too much. Erasing the equation, because we're moving on and we're doing it again with a different equation. I'll erase the contents of my table of values. Very smudgy, but we're getting close to the end of the lesson, so the closer I get to the end, the less I'm worried about the smudges. And I have to erase my dots. And this smudge here. But I'm also erasing that line, which means I'm making quite a big erasy smudge. A straight line shaped smudge. Yeah, we'll be able to see the ghost of this line y equals x plus 3 for a while. But I'm repairing my graph paper, my chalk wall graph paper. And it's actually going quite quickly, so I'm pleased. Orange chalk, just to repair my y-axis and my x-axis. Ta-da! I'm ready to do another one. Let's see now. How about the equation y equals x minus 2? Okay. I'm going to try doing 0, 1, 2, 3, and 4 as my 5 points, and we realize now I could just do 3 points. And if all 3 points are landing on the same straight line, we have a good feeling that we're doing it correctly. But 5 is even more of a way of making sure. So, okay, the algebras are going to be quite simple for this one. We have y equals x minus 2, and the first point I have is x equals 0, so y equals 0 minus 2. 0 minus 2 is equal to negative 2. So y equals negative 2, I have a point. How about this time, instead of graphing each dot as we get to it, we do all 5 algebras, fill in the table with 5 points, and then we graph them all at once. Y equals x minus 2. If x is 1, y equals 1 minus 2. 1 minus 2 is equal to negative 1. Y equals negative 1. Okay, third one, y equals x minus 2. X is 2 this time. Y equals 2 minus 2. Aha! 2 minus 2 is 0. Y equals 0. I have that point. We know what's going to happen with that point. When the y coordinate is 0, it's going to land on the x-axis. Okay, y equals x minus 2. X equals 3. Y equals 3 minus 2. 3 minus 2 is 1. No negative numbers involved in this one. Finally, y equals x minus 2. I'm going to skip 4 and do 5, just because I feel like it. Okay, therefore y equals 5 minus 2 is the point I decided to do. If y equals 5 minus 2, 5 minus 2 is 3, y equals 3. And now we can graph all 5 points. 0, negative 2. 0 means I'm not going to the left or the right. Negative 1, negative 2. There it is. Yes, it lands. It has an x-coordinate of 0. It lands on the y-axis. Let's skip ahead to 2, 0. X equals 1, 2. Y equals 0, which means it does not go up or down. If the y-coordinate is 0, it lands on the x-axis. If the x-coordinate is 0, it lands on the y-axis. How about this point? 1, negative 1. X equals 1. Y equals negative 1 right here. We see the dots are lining up into a straight line, which is kind of what we expected. We get used to the idea that this type of equation is the equation for a straight line. 3, 1. X equals 1, 2, 3. Y equals 1. And then skipping over 4. 5, 3. X equals 1, 2, 3, 4, 5. Y equals 1, 2, 3. Right there. And then I draw my line. And you can graph lines on a Cartesian coordinate system, but you can also graph curves. You can graph other things that don't form straight lines when they're graphed. We call them curves, but one of the things that's kind of funny about math is what I'm drawing right now, which we can refer to as a straight line or just a line, is also referred to as a curve, even though it's not curvy. So anything that you end up drawing on a graph from a table of values can be referred to as a curve. That was fun, and it was fast. It went much more quickly than the first one. I kind of chose better points because they also had a tendency to land on the graph more nicely. Remember, I can't put any y's that are smaller than -4 or higher than +4. I can't put any x's that are larger than 5 or smaller than -5. So I'm kind of handcuffing myself a little bit to not have too much choice of what I can do with this graph, but I still can do quite a lot, can't I? Okay, erase the algebras. Erase the equation. Erase these other algebras. I have time for 2 more, and the last one's going to be over here. So the second last one won't be erased from that graph, and we'll finally have gotten it as smudgy as it's going to get today. Okay, I have to erase these dots, but I also want to erase the line, the curve, which happens to be a straight line. And let's do a bit of repair. Not too bad. The repair happens quickly. Some messes from before that I never really fixed. It's not too bad. I need a bit of orange, that's all. Get some orange here and here. And we can do our last straight line equation that we're going to graph today. And it has the equation y equals 1/2 x plus 4. Y equals 1/2 x plus 4. There's a fraction in it. We can handle fractions. Okay, if x is 0, y equals 1/2 x plus 4 becomes y equals 1/2 times 0 plus 4. But 1/2 times 0 is still 0. So therefore y equals 4. 0, 4, let me graph it right away. 0 means I'm not going to the left or right, so the point is going to be on the y-axis. 1, 2, 3, 4. I can do this. We're getting good at this. Okay, how about if I make x 2? Over here. Y equals 1/2 times 2 plus 4. Well, that's an easy one. Doing 1/2 times an even number is easy to do in your head. 1/2 of 2 is 1. So we have y equals 1 plus 4. Y therefore equals 5. So we have the point 2, 5. 1, 2, 1, 2, 3, 4. Uh-oh, went too high, so I'm going to put it there anyway. Easy to estimate. May have put it a little too high actually, but anyway, I'm just going to keep going. How about if x is -4? Ooh, okay, y equals 1/2 x plus 4. Y equals 1/2 times -4 plus 4. Okay, slow down. 1/2 of 4 is 2, but 1/2 of -4 is going to be -2. Y equals -2 plus 4, which means y equals 2. And we have the point -4, comma 2, -1, -2, -3, -4, +1, +2, it's here. And we can see that 3 points is enough. Even though this one kind of went off the graph and might not be drawn perfectly, we're still able to graph our line. Notice how I graph the line all the way across the graph. I'll stop when I get to the edge of the graph, but I don't want to just draw in between my dots, because that gives the impression that the line only exists between these dots, and that's not true. A straight line just keeps on going. We know the definition of a straight line. It goes on in both directions forever, unless you stop it somehow. So I stopped it when I got to the edge of the little square of graph that I made. Now I'm going to do my last example. I only have 6 minutes at the most left. I'm not erasing that graph, but I'm going to erase the algebras that went with it and its equation. I'm just going to do one slightly more challenging one because I want to draw a curve that's actually curvy. How about, this is quite a simple one, but there is an exponent, y equals x squared. How about we do that one? We can still fill in a table of values. This is not the equation for a straight line. When you have your x squared, it's not going to form a straight line anymore when it finds its shape. If x is 0, y is equal to 0 squared, which means 0 times 0, but 0 times 0 is 0, so y is equal to 0. We have the point 0, 0, which remember, that's the coordinates for the origin. I'm not going to the left or right from the origin or up, down from... I have the point 0, 0. That's fine. How about if x is equal to 1? Do it here. Y equals x squared. Y equals 1 squared, but 1 squared is 1 times 1, therefore y is equal to 1. Oh, I have the point 1, 1. Is this going to keep happening? X is equal to 1, y is equal to 1. There we go. So far it looks like a straight line. How about if x is equal to 2? Y equals x squared becomes y equals 2 squared, but 2 squared is 2 times 2, which is 4. Oh, 2, 4. X equals 1, 2, y equals 1, 2, 3, 4. Okay, it's not a straight line. So the squaring of the x is doing something different than happened with those straight line equations. But we can still draw through these points, and we end up drawing a curve. That's cool. Wait, what if x is negative 1? Y equals x squared becomes y equals negative 1 squared, but notice how I use the brackets because I'm being careful. Negative 1 squared means negative 1 times negative 1. Negative 1 times negative 1 is positive 1. So I didn't get negative 1 as my y coordinate, I got positive 1. Negative 1, 1. Did we see that point before? Negative 1, 1. Negative 1, 1. I don't know. I don't think we did see it before, but we know how to graph it. Negative 1 means over here, and positive 1, oh, okay, this really is curvy, isn't it? One last point, negative 2. X equals negative 2. Y equals x squared becomes y equals negative 2 squared, which is negative 2 times negative 2, which gives us positive 4. Multiplying two negatives gives a positive, doesn't it? Negative 2, 4, negative 1, negative 2, positive 1, positive 2, positive 3, positive 4. And what we have is a lovely symmetrical curve which is dictated by the equation. And then we start to see the value of this lesson. What we're doing in our pre-algebra course is we're doing the Cartesian Coordinate System, which incorporates so many things that we already knew, like all this stuff about negative numbers, positive numbers, integers, adding, subtracting, multiplying integers, all sorts of stuff. But we get to learn this new skill, which is not really difficult, just takes a little bit of practice, where we can plot points or look at a point and identify its coordinates because we're familiar with the Cartesian Coordinate System. And then we're able to start graphing all sorts of interesting shapes. This is called the parabola, and it happens when the x in the equation is being squared. So as soon as you make a little change to the x in the equation, something happens to change the shape. It's really cool. There's a lot more to discover when we actually get to algebra, but I have to stop now because we're still in pre-algebra. But it is an exciting glimpse of what is to come. And I have reached the end of my hour, so I'm going to let the dog say goodbye, because she knows that it's supper time as soon as we say goodbye. And then she does her crazy little tap dance around the room. This dog, walking from where I'm standing to the door that goes upstairs, which is about 8 or 9 steps for me, she can step hundreds of times just getting from here to there. Let's see if I can make that happen. Okay, come here. Up, come on, up. Yep, yeah, you've slept enough. That's enough. You should have been paying attention to the math anyway, but I forgive you. I forgive you. Okay, would you like to have supper? Would you like to have supper? Let's see what happens if I put you down. Okay, I'm going to walk towards the door and we'll see if you can hear what happens. Okay, let's go. Come on, Malcolm. Okay. Okay, wait. I have to go back over here. Come on. Oh, gosh, you got back into the couch. Okay. So that is the way it always ends. I just thought I would try to catch a little bit of it in the recording. And now she's scratching. Okay, we will tap dance our way up the stairs. Thank you very much for being here. It was fun as usual, and I will see you next time.